Okay, so welcome to Natural Language Processing. My name is Michael Collins. I'm a professor in computer science at Columbia University. I've taught this course for several years now, most recently at Columbia and before that at MIT. Natural language processing is, I think, a tremendously exciting field. It builds on insights from computer science, from linguistics, and as we'll see, increasingly from probability and statistics. It's also having a huge impact in our daily lives. Many applications and technologies are now making use of basic ideas from natural language processing. So in this introductory lecture, we're going to cover a few basic points. The first question we're going to ask is, what is natural language processing? So we'll discuss a few key applications in NLP and also a few key problems that are solved in natural language processing. The second question we'll consider is, why is NLP hard? So we'll consider some key challenges that we'll find in natural language processing. Finally, I'll talk a little bit about what this course will be about, what kind of material we'll cover in this course, and what in general you should expect taking this course. So at a high level, natural language processing concerns the use of computers in processing human or natural languages. So on one side of this problem, we have what is often referred to as natural language understanding, where we take some text as input to the computer and it then processes that text and does something useful with it. At the other end, we have what is often referred to as natural language generation, where a computer in some sense produces language in communicating with a human or user. So we should first consider some key applications in NLP. One of the oldest applications, and a problem of great importance, is machine translation. This is the problem of mapping sentences in one language to sentences in another language. And this is a very challenging task, but remarkable progress has been made in the last 10 or 20 years in this area. So here I have an example translation from Google Translate, which many of you will be familiar with. This is a translation from Arabic into English. And while these translations aren't perfect, you can still understand a great deal of what was said in the original language. So later in this course, we'll actually go through all of the key steps in building a modern machine translation system. So a second example application is what is often referred to as information extraction. So the problem in this case is to take some text as input and to produce some structured, basically a database representation of some key content in this text. So in this particular example, we have input, which is a job posting, and the output captures various important aspects of this posting. For example, the industry involved, the position involved, the location, the company, the salary, and so on. And you'll see that this information is pulled out from this document. So the salary in this case comes from this portion here. So this is a critical example of a natural language understanding problem, where the problem is to, in some sense, understand this input, raw, unstructured text, and to turn it into a structured database kind of representation. So there's some clear motivation for this particular problem, information extraction. Once we've performed this step, we can, for example, perform complex searches. So say I want to find all jobs in the advertising sector, paying at least a certain salary in a particular location. This would be a search that is very difficult to formulate using a regular search engine. But if I first run my information extraction system over, say, all the job postings that I find on the web, I can then perform a database query and perform much more complex searches such as this one. In addition, we might be able to perform statistical queries. So we might be able to ask, how has the number of jobs in accounting changed over the years? Or what is the number of jobs in software engineering in the Boston area posted during the last year? Another key application in natural language processing is text summarization. And the problem in this case is to take a single document, or potentially a group of several documents, and to try to condense them down to a summary which in some sense preserves the main information in those documents. So here I actually have an example screenshot from a system developed at Columbia which is called NewsBlaster. And this is actually a multi-document system. It will take multiple documents on the same news story and produce a condensed summary of the main content of those documents. So in this particular example, we have a large group of documents all about some vaccination program. And here is a summary which attempts to capture the main information in all of these documents. So summarization, again, has clear motivation in making sense of the vast amount of data or text available on the web and in news sources and so on. It's very useful to be able to summarize that data. Another key application is what are called dialogue systems. And these are systems where a human can actually interact with a computer to achieve some tasks. So the example I've shown here is from a flight domain where a user is attempting to book a flight. And so the user might come with some query to the system, and the system then goes and processes this query. In some sense, it understands that query. And in this particular case, it realizes that there's a piece of missing information, namely the day of the flight. And so the system then responds with a query, what day are you flying on? The user provides this information, and the system returns a list of flights. So in dialogue systems, the basic problem is to build a system where a user can interact with a computer using natural language. And notice that this type of system involves both a natural language understanding component, we have to understand what the user is saying, and there's also, importantly, a natural language generation component in that we're going to have to generate text in some cases. For example, clarification questions, as we've shown here. So in addition to the applications I've just described, we'll also consider some very basic natural language processing problems which underpin many of these applications. And the first we'll talk about is something called the tagging problem. So abstractly, tagging problems take the following form. As input, we have some sequence, in this case a sequence of letters. And as output, we are going to have a tagged sequence where each letter in the input now has an associated tag. This is probably best illustrated through a couple of examples. The first one is part-of-speech tagging. So the problem in this case is to take a sentence as input, for example, profits soared at Boeing, Co., and so on, and to tag each word in the input with its part of speech. So N stands for noun, V stands for verb, P stands for preposition, ADV stands for adverb, and so on and so on. So this is one of the sort of most basic problems in natural language processing. If you can perform this mapping with high accuracy, it's actually useful across a very wide range of applications. A second example of a tagging problem is what's called named entity recognition. So the basic problem here is, again, to take some sentence as input, and now to identify basic entities in that sentence. So entities are things like companies, so we have Boeing, Co. here, locations, Wall Street here. We might also, for example, identify people. Again, named entity recognition is a very basic problem, but it's clearly very useful in many applications to be able to identify companies, locations, people, and other entity types. This problem can again be framed as a tagging problem, where each word in the input is tagged either as not belonging to any named entity, so NA means we're not part of an entity, or we might be part of a company. SC means we have the first word in a company, this is start company. CC means we have the continuation of a company, and similarly SL means we have the start of a location. CL means we have the continuation of a location. So again, abstractly, a tagging problem is the problem of mapping an input sequence of items, usually words, to some tag sequence where each word in the sequence has an associated tag. These are two key problems, and there are many, many others. Another basic problem in natural language processing is the problem of natural language parsing. And this goes back to work in linguistics, going back to sort of the foundation of modern linguistics with Noam Chomsky's work in the 1950s. The problem here is, again, to take some sentence as input and to map this to some output, which is usually referred to as a parse tree. So we'll talk a lot about this later in this course, but at a very high level, the parse tree essentially gives some hierarchical decomposition of a sentence corresponding to its grammatical structure. And once we've recovered these kind of representations, we can, for example, recover basic grammatical relations, the fact that Boeing is the subject of this verb is, or the fact that this prepositional phrase in Seattle is a modifier to located. So again, this is a very basic problem in natural language processing. We'll see that if you can recover these representations with high accuracy, it's useful, again, across a very wide range of applications. It's, again, a first basic step in natural language understanding and trying to make sense of what an underlying sentence means. And it's also a quite challenging problem.